Hello everyone, welcome to GitHub Hot today. Today's projects are freeCodeCamp, a comprehensive open source platform for learning to code with interactive challenges and certifications, llama.cpp, a high-performance C, C++ library for running large language models locally on various hardware, and personaplex, an NVIDIA project enabling real-time, full duplex conversational speech with customizable voice and role control. freeCodeCamp is one of the largest open source learning platforms, built by thousands of volunteers. If you want to contribute, their contribution docs break it down into clear paths. You can work on curriculum challenges, fix UI bugs, improve documentation, or even help with translations. Each path has its own step-by-step guide. Setting up locally used to be a pain, but now they support GitHub code spaces. You get a pre-configured dev environment in your browser with Node, JS, MongoDB, and all dependencies ready. If you prefer local development, the setup guide walks you through forking the repo, cloning it, and running npm install. They even have selective build options to speed up curriculum work. The codebase follows strict best practices. They use a shared component library called freeCodeCamp.ui, enforce TypeScript naming conventions, and have detailed Redux patterns. Testing is split into unit tests adjacent to source files and integration tests in a dedicated directory. Everything runs through their linter before you submit a PR. Beyond the main platform, they also run a massive technical blog with over 12,000 articles. Topics range from AI automation to Kubernetes authentication. The project is transparent about what they are not accepting right now. For instance, curriculum translations are paused while they explore new approaches. llama.cpp is a pure C/C++ LLM inference engine designed to run large language models locally with minimal setup and maximum performance across almost any hardware. It supports over 60 text models like llama, Mistral, Qwen, and Gemma, plus 12 plus multimodal models for vision and audio tasks. The real power lies in its backend support. You can run inference on Apple Silicon via Metal, NVIDIA GPUs with CUDA, AMD GPUs through HIP, or even Intel GPUs using SYCL. For CPU-only setups, it leverages AVX512, AMX, and ARM Neon instructions. There's also Vulkan, OpenCL, and Web GPU support for broader compatibility. Building is straightforward with CMake. Just clone the repo, run cmake-b build, then cmake-build build. For GPU acceleration, add flags like -dggml CUDA equals on or -dggml metal equals on. Once built, you get several tools. llama.ci lets you chat with models directly from the terminal, supporting custom chat templates and grammar-constrained output. Llama Server spins up a lightweight HTTP server with an OpenAI-compatible API. It supports parallel decoding for multiple users, continuous batching, and even has a built-in web UI. You can configure hundreds of parameters: context size, batch size, GPU layer offloading, sampling strategies like temperature and top P, LoRa adapters, and more. Multimodal support arrived recently via libmtmd. You can now run vision models like Gemma Tree, Qwen2VL, and IntanVL, or audio models like Ultravox and Voxtra. Just use the -hf flag to download a model directly from Hugging Face, or specify a local gguf file with --mmproj for the projector. For performance optimization, speculative decoding can significantly speed up token generation. You can use a small draft model or n-gram-based methods without any extra model. The ops matrix shows exactly which tensor operations are supported on each backend. Green checkmarks mean full support, yellow dots are partial, red crosses mean not supported. Quantization is a key feature. You can run models at 1.5-bit to 8-bit precision, drastically reducing memory usage while maintaining reasonable accuracy. The ecosystem is massive, 40+ language bindings for Python, Rust, Go, JavaScript, and more, plus 50+ UI applications like LM Studio, Ollama, and Jan built on top of it. One limitation: if you need advanced GPU scheduling for large-scale production, you'll likely need to customize the CUDA kernels yourself. The built-in scheduler is functional but basic. Getting started takes minutes. Install via brew or Wingit, grab a GGUF model from Hugging Face, and run llamaserver-hf.ggml.org Gemma 3.1b it gguf. You're done. NVIDIA just dropped personaplex, and it finally solves the biggest trade-off in conversational AI. You used to have to choose between natural, real-time dialogue or customizable roles and voices. Personaplex gives you both. Traditional ASR to LLM to TTS pipelines let you pick a voice, but the conversation feels robotic with awkward pauses. Full duplex models like Moshi fix the timing but locked you into one fixed persona. Personaplex breaks that lock. Here's the core innovation: hybrid prompting. You feed it 2 inputs before the chat starts. a voice prompt, which is just a few seconds of audio to clone the tone and style, and a text prompt, where you define the role, background, and context. The model processes these jointly, so you can tell it to be a wise teacher, a bank customer service rep named Sunny, or even an astronaut dealing with a reactor meltdown on Mars. It maintains that persona throughout the entire interaction. Under the hood, it's built on the Moshi architecture with 7 billion parameters. It uses the Mimi neural audio codec to convert speech to tokens, then runs them through temporal and depth transformers. The dual stream setup lets it listen and speak at the same time. This means it handles interruptions, backchannels like aha, and natural turn-taking without those weird cascaded delays. The latency is down to 170 milliseconds for smooth turn-taking, which is faster than Gemini Live and Qwen Omni. Training data is where it gets clever. They took 7,303 real conversations from the Fisher English corpus and used an LLM to retrospectively generate persona descriptions for each speaker. Then they blended that with over 100K synthetic customer service dialogues. The result? It learns natural speech patterns from real humans but gets task-following ability from the synthetic data. In benchmarks, it scores 4.29 out of 5 on task adherence judged by GPT 4.0, beating Moshi and Freeze Omni. You can grab the 7B model weights on Hugging Face right now. It runs on PyTorch, needs an NVIDIA Ampere or Hopper GPU, and operates at 24 kHz sample rate. The code and weights are under MIT and NVIDIA Open Model license. One limitation to note, it's English only for now, and the voice cloning is based on a short audio embedding, so it captures style and prosody but isn't a perfect one-to-one voice replica. But for building role-specific agents, this is a massive step forward. That's all for today's show. See you tomorrow.